Hello, my name is Eric Gans. I'm with Mercury Systems, and I wanted to show you some of the exciting software and hardware we're showing at AUSA this year. So specifically what you're seeing on this screen is our DCESA AITR that we're supplying for the Army's advanced teaming program, so supporting manned-unmanned teaming efforts and specifically advanced threat recognition within drones. So what you see on this screen is actually a split screen showing what it looks like on an individual drone with a smaller processor that we produce, which is a small form factor NVIDIA Jetson. And on the left side, you see it running on a larger CMOS aligned box. We're actually showing 9 drones being processed simultaneously. And what specifically is being processed is EOI imagery is being analyzed for the presence of threats, and our software intelligently determines the location of that threat, the type of threat, and will display to operators the level of confidence in said threat. And so here on the right hand, you see a series of tanks passing through the field of view, being identified, in this case some just damaged armored personnel carriers. And this imagery isn't passed across the network. This is what the drone itself were to see. But on the bottom you see, to reduce the amount of information shared on the network due to low communication bandwidth, is a small, what we call a chiplet, which is an individual still of that threat, the type of threat, and the confidence level. And the trick we apply here is some contextual reasoning, which is basically human level logic. So for example, ATR might be able to see some tank that's sitting on a mountaintop, and that's typically a false positive. And so a human operator would know that that is not realistic. And so we apply that type of human level logic in here, considering things like terrain, environment, and other conditions to increase the level of confidence in that threat and be more intelligent for an actionable response. As I said here, we have a small form factor processor, so this is something that would run, let's say, on the drone itself, on let's say an Altius 600 drone, which we are using under this program. On the left side, this is something you would see on perhaps a Blackhawk that is actually deploying these air-launched effect drones. So this is a CMOS aligned processor, 3U Open VPX. Specifically, this is NVIDIA RTX 5000. Significantly more powerful than the Jetson board, and that's why you're able to process, let's say, 9 drones simultaneously. And so, to give you a comparison for the level of capability that Mercury can provide both in hardware and software, in terms of AI and threat recognition on the software side, and the ability to host it on a variety type of processors depending upon your platform and operation needs.